Hello everyone, we are going to introduce what is Euler paths and circuits. Our team consists of 5 members who are Munka Singh, Dan Dongji, Chinshi Singh, Serenpe, and Divanish. And each of us will explain a section of the topic today, and Divanish will be our video editor today. So let me introduce myself. My name is Dan Dongji, and I'm going to explain some of the basic concepts of this topic. Like, what is the vertex? Vertex is a corner or point where lines meet. For example, a square has 4 corners, 1, 2, 3, and 4, and each corner is called a vertex. What's the degree? In graph theory, the degree of a vertex of a graph is the number of edges that is incident to the text. In multi-graph, loops are counted twice. For this example, we have point A, point B, and point C. We know that point A is degree 1 because the number of edges that is incident to the vertex A is 1 edge only. And from point B is degree 2 because there are 2 number of edges that are incident to point B. The point C is same as the point A. We look at another example, point D and point E. We know that point D is degree 1, but the point E is degree 3 because the loop is counted as two number of edges that are incident to the vertex E and plus the edge that are linked with D and E. So there are other basic concepts that you need to know before entering the topic. That's the end of my section.
Okay, hi everyone, I'm Serene. Let us continue to Euler path. So what is Euler path? An Euler path is a path that uses every edge of a graph exactly once. So the conditions for Euler path is the Euler path if all the vertices have even degrees except 2 having odd degrees. So let us see for the first example. So this is the example 1. So let's say we have a graph like this. If we construct a path that visits all the edges of the graph exactly once, then the particular path is an Euler path. So we can have a path that goes from this A to B to C to D, which is visit all the edges exactly once. So we look at the vertex D. This is 1 degree because it's connected to one line, and we come to the vertex C. This is 2 degrees because it's connected to 2 lines, and also vertex B is 2 degrees because it's connected to 2 lines, and also vertex A, which is 1 degree because it's connected to 1 line. So from the conditions and from the definitions we have given, we can conclude that this is an Euler path. So next, how we construct an Eularian path? So there are 2 conditions for it. So first one is starting from vertex having odd degree and also end with vertex having odd degree. So let us see from the first example. We can start from the first degree, this D vertex, which is we have 1 degree, which is odd degree. So we can start from D to C to B to A, which is end with a vertex that have 1 degree. So also in another way, we can also start from A vertex, from A to B to C to D. But we can't start from a vertex that having 2 degree, which is even degree, because when we start from this degree, C vertex, we start from here. If we start from C, we can only go to vertex D or go to vertex B. So if we go to vertex D, we will be missing out 2 vertex, which is vertex B and vertex A. But if we go to vertex B and vertex A, we will be missing out from the vertex D. Therefore, we can conclude that if we want to construct an Eularian path, we must starting from a vertex that having odd degree and end with vertex having odd degree. That's all for my explanation for Euler path.
So I'm Shusen. I'm going to talk about what is Euler circuit. So what's an Euler circuit? An Euler circuit is a path which uses every edge exactly once and start and end at the same vertex. And in other words, Euler circuit is a Euler path that start and end at the same vertex. Let's have an example. This graph with Euler circuit would be something like this. There was a path from A, go to B, go to C, go to D, and come back to A. As we can see, we start at A and we also ended at also A. And we are visiting every edges exactly once. Therefore, it is an Euler circuit. So let's look at example 2. Let's say we have a path like this. We start at, let's say, B, we go to C, come back to C, we go to D, go to E, and come back to A. Same as example 1, we start at this point, and we also ended at the same point, which is B. So at the same time, if visiting every edges and start at end at the same vertex. So this is also an Euler circuit. Next. When a graph, if a graph have an Euler circuit, it's called an Eularian or unicursal. There's a condition same as Euler path. There's a condition where a graph have an Euler circuit. When a graph have the condition for a graph to have an Euler circuit is a graph will have an Euler circuit if the degrees of all its vertices is even. So this two is an example. Both of these graphs have even degrees in all of its vertices. Let's say if the graph have 1 or 2 vertex with odd degrees, it's not an Euler circuit anymore. That's all from me. Thank you.
Everyone, my name is Sean. Before I start my lesson, I have a question for you all. Can you take a walk through the bridge at house, visiting each part of town and crossing each bridge just only once? No, you can make it. This type of bridge is known as 7 Bridge of Königsberg. The map can further simplify into this type of diagram. Each vertex in the diagram represents the town and the edge is represent the bridge. In this diagram, we can see that C have 5 degrees, which is from Q, P, R, S, and T, and A has only 3 degrees, which is from P, Q, and U. And D has also have 3 degrees, which is from T, U, and V. B also have 3 degrees, which is R, S, and V. So the diagram is clearly so that it's impossible to walk through the town and visiting each part of the town and crossing each bridge by only once. This shows that it's not a Euler path. Then we can add a new line from B to D. This will make the both vertices in B and D become 4 degrees, and this will make the diagram now consists of 2 odd degree and 2 even degree. So the diagram is now changed into Euler path.